Hi everyone, and thanks for watching. I'm David Howes and I'm the author of Textpression. So what is Textpression? Well, after using Regex for a while, I started noticing that I was having some recurrent issues. I love the power of Regex, but I found the syntax hard to remember, I found it difficult to read, and I found it was kind of prone to typographical errors, such as missing brackets. I also found that I was frequently cutting and pasting parts of my regexes from one place to another. And finally I found that I was often missing the functionality I needed to achieve specific tasks, and ended up combining multiple regex with scripting code in situations where I would have preferred to use a single regex. So when I wrote Textpression with the aim of solving these problems, the requirements were a simplified graphical representation of regex, a way of reusing subexpressions within an expression, and some extensions to standard regex functionality. During this video, I'm going to start by showing you an overview of what Textpression can do. I'll be creating some simple expressions, showing how you can reuse parts of expressions, and then carrying out some matches and replacements. Following that, there'll be an overview of where the development process is at and where it's going. And finally, I'll cover what you can do to help shape Textpression's development. In a moment we'll see Textpression in action, but before we do that I just want to talk briefly about the concept of modules within Textpression. In Textpression, regex are held in modules. Textpression has two module types, standard and extended. Standard modules are compatible with regex flavours such as .NET, Java, PHP and so on. Extended modules allow a superset of the functionality in standard modules. Multiple replacements in single operations and other enhanced functionality is available. We're going to stick with standard modules for now, but we'll take a look at Textpression's extended functionality later in the video. Here's how Textpression looks when it first starts up. It's currently showing the welcome page. This allows you to create new modules, new projects, open existing modules or open existing projects. If you create a new module, you can create either a standard module or an extended module. So if you create a standard module, then the module will be convertible to regex such as .NET, PERL, Java and so on. Extended modules have some additional functionality but aren't convertible to standard regex. So let's create a standard module, and if we have a look in the expression area here, we can define the pattern of text that we're going to look for. We can do that by either dragging in components from the component chooser on the right hand side, or by simply typing in a pattern of text. So let's look for cat, and we need to look for that pattern of text in something. We're currently looking within a file selection. If we show the files and folders here, we could search within program files, for example. So we've selected program files and we would look for cat in all the files within program files. However, let's just look for it in a text box for the time being. So let's type in some test text and let's do a search for cat. Okay, so we've matched the word cat within our test text. We could look for pet as well, so let's create another module, another standard one, and let's look for pet this time. And there we go, so we match pet. If we look in the bottom part of the screen here, this is the conversions area. You can choose the conversion language and you can choose a snippet. So the pattern of text that you type in the expression area gets converted to a regex and is usable within whatever snippet you choose. A little bit more on that later on. When you want to find text containing one of a number of alternatives, the regex solution is alternation. So for example, if you wanted to find all occurrences of the words cat, dog or mouse within a single search, then you would create an alternation that contained each of these words. When you create an expression containing many alternations, especially nested alternations, you might find it difficult to maintain an overview of the expression as a whole. You may want to restrict your view of the expression so you can focus on just the path through the expression that you're interested in at a particular stage of the expression design. We'll take a look now at how Textpression allows for this. Okay, if we look at the top of the screen here in the text box, we've got a couple of employee type records, and we want to match those records which have either a software engineer or web designer as the occupation, and we're going to do that using an alternation. So we're going to drag that in from the component chooser, and we're going to put in web designer, or alternatively software engineer. Okay, so let's go ahead and search for those two. So on line 2 we've matched software engineer, and on line 6 we've matched web designer. The different colours here are just to signify different matches. Okay, so if we go back to our alternation, there's some different ways we can lay this out. We can either show all of the two alternatives, or we can just show one at a time and navigate in between them, or we can lay it out vertically. So if we lay our alternation out vertically, then the little divider line turns into a friendly text string, and we also get this collapse button here which allows us to hide the alternation altogether. If you need to specify that a pattern of text may be matched a specific number of times in succession, you need to use quantifiers. Regex have two basic modes of quantifier behaviour. The first is greedy matching. Here, as many characters as possible will be matched within the upper and lower bounds specified. The second is lazy matching, where as few characters as possible will be matched within the upper and lower bounds specified. Textpression also supports a variation of greedy matching, known as possessive matching. Okay, let's take a look at quantifiers. If we look at the text box above here, we've got three sequences of digits that are comma separated. What we want to do is we want to match the digit sequences but not the commas in between. So we're going to drag in a quantifier, and we're going to change the lower bound to 1, leave the upper bound at U for unlimited, and leave the match type as greedy, and then we're going to drag in a digit. So what we're saying here is we want to match between 1 and unlimited numbers of digits, and we're going to match greedily. So by greedily we're going to match as many as possible within the bounds 1 to unlimited. So let's give that a try. Okay, so our first match is 1, 2, 3, second match is 4, 5, 6, and third match is 7, 8, 9. If we search lazily, then we'll match the minimum possible number of digits within the bounds of 1 to unlimited. So each match should be 1 digit. So let's try that. Yep, and the first match is 1, the second is 2, third is 3, and so on. We can lay out quantifiers in a vertical way and get a little collapse box in the same way that we did with alternation. Identifiers are a key concept in Textpression. They can be used in a number of ways: as capture groups and back references from traditional regex, as placeholders for text strings, or in much the same way as you would use variables in programming or scripting languages. Here's how you use a identifier as a placeholder. If we look at the text above here, we've got various sentences relating to pets. Now we can search for snake and we'll match snake. However, we can also drag in an identifier, change the name to pet name, and change the value to snake, and we can drag in a reference here, and now we can search for snake again. Right, let's see identifiers used within capturing. If we take a look at the text box, we've got some HTML here. The first tag pair is valid, the second tag pair is valid, the third tag pair isn't valid because the opening tag isn't the same as the end tag. What we want to do is we want to match the valid tag pairs. So I'm going to create an expression to do that. So I want a open bracket, then I want an alternation for either H1 or H2 or H3, and then I want to close bracket. Then I want to match anything basically in between the open and close tags. So got any char, we use a quantifier, and we're going to say between 1 and unlimited numbers of characters, and we're going to match greedily, and then we need to match the closing tag. So we need a open bracket, and then we need to match the same tag in the close that we matched in the open. So we're going to do that by dragging in an identifier. We're going to call it open tag, and we're going to drag a reference just after the alternation, and then we're going to select everything in the alternation and also the reference to the identifier, and we're going to choose named capture. So what we're doing is we're capturing either H1, H2 or H3 to open tags. So we're remembering H1, H2 or H3 in open tag. So what we can now do is we can drag a reference just here, and we're going to need a slash and a close tag. So hopefully I've got that right. Okay, let's give that a try. Okay, so we matched line 1, which is the first tag pair, and we matched line 3, which is the second tag pair, but we didn't match the line 5 because that's invalid. As well as using Textpression to process text directly, you can also convert standard modules to code snippets that can be used in a variety of coding languages. Different languages support different regex flavours. The code snippets available for each language will therefore vary depending on the support offered by its associated regex flavour. Currently, Textpression supports C#, VB.NET, Java, Delphi, PHP, JavaScript and PERL. Some of these may be restricted in the initial alpha releases, and final support will depend on user interest, but the majority of major languages will be supported. I also anticipate adding additional support during product updates free of charge. Okay, in the text area above, we've got 3 sentences. They each relate to pets. So what we want to do is we want to match any of the pets, and we're going to do that using an alternation. So as I type in the different pet names, watch the conversions area below here. Okay, so we go for cat and dog and snake. So as I create the expression, the regex is automatically created in the conversions area below. It's created using the C# language, and we can choose a snippet according to the functionality that we want the regex to be included within. So let's go for an if-else substring match, and we'll just expand that out a little bit. So within the try part of a try catch here, we check to see if source string matches the regex pattern. If it does, then we execute whatever code we choose to include here, and if it doesn't, then we execute whatever code we choose to include here. A fly in the ointment when it comes to reusing regex from different sources is string escaping. I'm not going to go into a lot of detail here, but many coding and scripting languages allow for escape sequences within strings. These escape sequences allow you to insert, for example, tabs and line breaks. The problem is that regex also use escape sequences, which the interpreter or compiler for the language you are using may assume it is meant to handle. To prevent this from happening, you need to add language level escaping to the regex string before it will be used within code. Although you can use Textpression to develop your regex from scratch, Textpression will also let you reuse regex that you find elsewhere. So if you find a regex example in a blog, for instance, then you can paste it right into Textpression and then either modify it or use it unchanged. Textpression has a number of so-called paste from options that will strip language-based escaping from any of the supported languages. So all you need to do is select the source you copy the regex from and then paste it into Textpression. Incidentally, when you paste in a regex, the regex gets validated. This will catch common errors such as missing the final parenthesis off when selecting the regex from its source. To paste a regex into Textpression, you just have to select a regex from somewhere, and we've got one that will match an email address here, so we'll just copy that to the clipboard. Go back to Textpression and then select paste as regex. Okay, let's add a couple of line breaks in. And there we go, there's our email address matching regex. Module insertions are literally just that. They allow you to reference an external module within a current module. You can use module insertions within either standard or extended modules. If the external module contains identifiers, then you can override the value of those identifiers within the current module. When you process a module, any module insertion references are automatically expanded. You can also save a module in an expanded form. Okay, let's take a look at module insertions. I'm going to start off just by creating a standard module. And if we look at the text above in the text box, we have the text "I have a pet cat." So let's just do a standard search for that for the time being. And let's just check that works. Yeah, okay, so we match "I have a pet cat." Now what I'm going to do now is I'm going to drag in an identifier. I'm going to call it pet name, and I'm going to give it a value of cat and substitute a reference to it for the word cat. So what we should do now, we should match "I have a pet" and then the contents of pet name, which should be cat. So we should still match "I have a pet cat." So let's just try that. Yeah, okay, so we get a match. Okay, let's just save module 1 as, we're going to call it external module. Okay, now let's create another module, and we're going to call it including module, because it includes the external module. Okay, so in our including module, we are going to drag in a module insertion reference, and we're going to drag in a reference to the external module. So what we should get now is we should still be able to match "I have a pet cat." So let's just try that. And great. So we get the match. The reason we get the match is because when we drag in that module insertion reference, it literally includes everything at match time, which is in external module. So it's as if the contents of external module were at this insertion point just here. Now, you may have noticed when I dragged in the module insertion reference, we also got a copy of the identifier, which is in the external module. Now, the identifier had its value set to cat in the external module, but we can override that in the including module to dog. Now, if we try matching now, we don't get a match. However, if we change the text above to dog and we try and match again, we get our match that time. So you can override the value of identifiers in external modules when you include them via a module insertion reference. So what should be fairly obvious is that when we actually hit the process button here, everything from the external module was included into the including module. So we can also do this manually as well. I go to File and Expand As. Now what that will do is it will expand any module insertion references within the current module and create a file with a module with all the references expanded out. So let's just do that. So we see by default the name of the expanded file is the current module name with an underscore and exp on the end for expanded. So if we save that, then what we get is I have a pet, then a space, and then the reference to pet name. So there's module insertions. Okay, we're going to take a look at extended modules in Textpression now, starting with function calls. Function calls allow you to specify another module within an expression which will take text as an argument and return text as a result. Passing text to and retrieving processed text from a function call is achieved via identifiers. A function call within an expression has a predefined identifier as its source and another as its result. You can capture to or copy to the source identifier. You can also simply use an identifier that has been initialized with text in the module creation stage. Function calls can be recursive, which is useful if you want to deal with, say, nested HTML. To demonstrate function calls, I've partially created a module here which matches any of the pet names and captures them to an identifier called pet name. I've also created a module called uppercase which accepts lowercase letters and converts them to their uppercase versions. Okay, so to demonstrate the function call itself, the way function calls work is they take text as argument and return text as a result. The text they return as a result is the text that they accept as arguments with any replacements made. So in the case of uppercase, we'll get the text back that we put in, but in an uppercase form. So let's make the function call itself to uppercase. And we notice when we do that, let's just hide the components for a second, we get a couple of identifiers that we may not be expecting. We always get these when we drag in function call references. The first one is source string and the second one is results. Source string is the identifier that you will assign to, and results is the identifier that will contain the changed text from uppercase. So let's make an assignment to source string, we're going to do that with a identifier copy. So what we want to do is copy pet name to source string, and then what we're going to do is we're going to replace each pet name with the uppercase version from the result of the call to uppercase. So let's just try that, and there we go, we get the uppercase version of each of the pet names. A quick aside here is that function calls can also be made to the calling module. So in other words, you can make recursive calls. The way you use replacements in Textpression depends on whether you are creating a standard or extended module. Standard modules take a single search pattern, and if you are making a replacement, a single replacement pattern. Extended modules allow you to mark out multiple parts of the search pattern for replacement. Replacements get carried out after the match as a whole is completed. However, if any identifiers are used in the replacement, then the value of the identifier when the text within the replacement subsection was matched will be the value used. We're going to take a look at replacements now and the difference between replacements in standard and extended modules. So I'm going to create a standard module first, and if we take a look at the text above, we can see some references to the family's pets. I have a pigeon, I have a snake, and I have a cat. So we're going to search for either pigeon, snake or cat, and then we're going to replace it with something else. So we're going to use an alternation, and I'm going to put pigeon, snake and cat in as the alternatives, and then I'm going to make a replacement. So pigeon or snake or cat will get replaced with pet. So what we're going to search for is pigeon, snake or cat. What we're going to replace the words pigeon, snake or cat with is the word pet. So let's give that a try and see if it works. Okay, so what we see here is pigeon has been replaced with the word pet, snake has been replaced with the word pet, and cat has been replaced with the word pet. So that was a replacement within a standard module. So let's take a look at replacements within extended modules. So let's create an extended module. So we're going to use an alternation again. So I'll just go back and copy the one from the standard module and paste it in here. But this time what we're going to do is, depending on the pet that we match, we're going to make a different replacement. So just to make this a bit easier to read, I'm going to change the alternation so it has a vertical layout. Okay, and I'm going to make different replacements for pigeon, snake and cat. So if we match a pigeon, we're going to replace it with bird. So if we just select pigeon and then select replace and then type within the green area bird, and then if we match a snake, we're going to replace that with reptile, and if we match cat, we are going to replace it with feline. Now notice at the moment that all the text within the green area is greyed out. That's because by default Textpression won't actually make any changes unless you are in search and replace mode. So if we ran it at the moment, we would get matches for pigeon, snake and cat, but we wouldn't get any changes. So we want to change the mode to search and replace, and now we will get the replacements. So let's give that a try, and we're going to accept all changes, and there we go. We've got pigeon replaced by bird, snake replaced by reptile, and cat has been replaced by feline. Okay, moving on to the equality. The equality in Textpression is fairly straightforward in its operation. It takes two sets of arguments and compares the concatenation of the first set against the concatenation of the second set. If they match, then the parser continues matching. If they don't, then matching fails at that point. We're going to take a look at equalities now with the aid of a module that I created earlier. Let's just take a quick look at the module itself. We have an outer alternation, which encloses three alternatives, and within those alternatives, each alternative starts with an equality and is followed by another alternation. Now what an equality does is it's an assertion. It doesn't match anything by itself, but it has to evaluate to true in order for matching to continue within either the expression as a whole, if the equality is in the expression as a whole, or within a alternative if we are inside an alternation. So to give an example here, we can see the equality in this case checks that the pet type is set to reptiles. If pet type is set to anything other than reptiles, then we won't be able to continue within this alternative. So we can proceed to the next alternative though, where pet type is set to birds. That assertion will be true, so we can then match either budgie or pigeon. So let's give that a try. We shouldn't match any snake or lizards, but we should match budgie and pigeon, which Kate owns. So let's see if we can match Kate's budgie and pigeon. Great. Okay, so we match the budgie and the pigeon that Kate owns. So let's try that again for felines. So we should match the cat and the tiger that Rob owns this time. So let's give that a try. Great. Okay, so we've matched Rob's cat and tiger, and the final one is reptiles. So let's just try that. And there we go, we've matched the snake and the lizard that I own. The next piece of extended functionality in Textpression is the identifier copy. The identifier copy does just that. It allows you to copy identifiers. You either copy plain text or the values of other identifiers. The identifier copy is particularly useful when you want to concatenate text during repeated captures. Alright, we're looking at identifier copies here. We've got a fairly complicated module to demonstrate this example, but I think it's worth it because it does show the power of identifier copies. So I'll take the module one step at a time. What we're basically going to do is we're going to try and match all of the text and replace all of the text with a sentence containing just the pet names and a bit of precursor text. Okay, so the way we're going to do that is we have an outer loop just here, which we're doing with a quantifier, and the first thing that is going to be matched within that loop are as many characters as necessary before one of the pet names. The pet names are all within this alternative, which we've squidged down here just to save a bit of space on the video, but they are all in there. And when we match a pet name, we're going to capture it to the identifier current capture. When we've done that, we are going to concatenate the contents of cumulative capture plus a space plus the contents of current capture to cumulative capture. So obviously cumulative capture will start off empty before the first pet name match, but after the first pet name match, then it will accumulate pet names for each pet name which is matched. So we'll start off matching snake plus a space, then we'll have lizard plus a space, and then so on through the pet names. When we've matched a pet name and concatenated it to the cumulative capture, then we will match any characters after the pet name. Again, we are matching lazily, so the quantifier is lazy here. If we didn't have a lazy quantifier, then we'd end up grabbing every character until the end of the text, including any of the pet names. All we want is just the characters until the next pet name. So the cumulative capture will be a list of pet names. So let's give that a try. We're going to accept all changes here, and there we go. So the text as a whole has been matched. You can see it here in red, and the replacement is the precursor text plus a space plus the list of pet names. We could have neatened this up a little bit. We could have had some commas in, put some additional checks in to make sure we didn't get the additional spaces here that we don't need. But I wanted to keep the module simple for the video. Okay, so that's identifier copies. Okay, so right now Textpression is very much at the alpha stage. I haven't encountered any destructive behaviour, but I wouldn't recommend installing it on a production machine for now. Although most of the final functionality does work, there's some functionality disabled at the moment. The replacement functionality is disabled until I can carry out some more testing, and the only language supported at the moment is C#. Performance is also currently very slow, at least in the parser itself. The parser was built from the ground up and it hasn't been optimised at all yet. There probably aren't going to be any massive changes in functionality. Some of the icons, artwork and the look and feel will probably change a little depending on user feedback. And finally, the planned availability is later this year. I haven't made any decisions on pricing yet though. If you want to help make the first release of Textpression the best it can be, then the following would be helpful. If you encounter a bug, for now just post in the appropriate forum section. You can get to the forum through Textpression's help menu. I'll be looking at adding a more formal bug reporting setup later. If you want to make any comments and suggestions, then again the forum is the best place to do this. I really appreciate any constructive feedback, and although I'm not paying anyone, those people who make the most significant contributions may be offered free copies of the final product. That's it for now. Thanks for watching. Any questions you can email me direct at davidhowes@textpression.com, or probably better in most cases, make a post on the forum and I'll answer as soon as I can.